18.6. The Spearman rank order correlation coefficient. In chapter 14, you learn about the correlation coefficient, R, which measure both the strength and the direction of the relationship between two variables. This coefficient requires both variables to be at the interval or ratio level of measurement. In this section, we will introduce a non-parametric version of the correlation coefficient known as the Spearman rank order correlation coefficient, or RS. This latest statistic also measures the strength and direction of the relationship between two variables, but only requires the data be at the ordinal level of measurement. The Spearman rank order correlation coefficient can be found using equation 18.10, where RS is the Spearman rank order correlation coefficient. D is the difference between ranks of each pair of observations. N is the number of ordered pair. To demonstrate using equation 18.10, we will rely on the original correlation example used in chapter 14. Suppose we would like to investigate the relationship between the number of hours students study for a statistic exam and the grades they get for that exam. Table 18.26 shows sample data for 6 students who were randomly chosen. This data can also be found in the Excel file examgrade.xlsx. To calculate the Spearman rank order correlation coefficient, we first need to rank each variable from low to high values and calculate the difference in the ranks between the variables. We will show this calculation in table 18.27 and explain the 7 columns as follows. Column 1, 2, and 3 are the original data from table 18.26. Column 4 is the rank hours from column 2. For example, student 1 and student 5 both studied 3 hours. The students are in the second and the third position in our sample. We assign both students the average of 2 and 3, which is a rank of 2.5. Column 5 ranks the grade from column 3. For example, student 1 has the lowest grade, 78, and is given the rank of 1, whereas student 2 has the highest grade and is assigned the rank of 6. Column 6 is the difference between column 4 and column 5. For student 1, the difference is 2.5 minus 4 equal to minus 1.5. Column 5 is found by squaring the value from column 6. For student 1, the result is minus 1.5 square equal to 2.25. We now need to sum up column 7 in table 18.27. Summation of d square equal to 8. We are now ready to calculate the Spearman rank order correlation coefficient using equation 18.10. Note that n equals 6 because we have 6 students in our samples. RS is equal to 0.771. The interpretation for the Spearman rank order correlation coefficient is the same as the correlation coefficient discussed in Chapter 14. The Spearman rank order correlation coefficient RS provides us with both the strength and direction of the linear relationship between two variables. The values of RS range from between -1 and +1. When RS is positive, the linear relationship between the variable is positive. This means that as the value of one variable increases, the value of the other tends to increase. By contrast, when RS is negative, the linear relationship between the variable is negative. So, as the value of one variable increases, the value of the other tends to decrease. When RS is close to 0, there is no relationship between the variables. Because RS is equal to 0.771, we can conclude that there is a very strong positive relationship between the number of hours students study for an exam and the grades they get on it. However, this result is based only on a small sample of 6 students. Does this result provide enough evidence to support the conclusion for the entire population of students? To answer this, we need to perform an hypothesis test with the following step using alpha equal to 0.05. Step 1. Identify the null and alternative hypothesis. In our exam grade example, we define the population rank correlation coefficient RS as the rank correlation for the population of students. The purpose of this hypothesis test is to determine if there is a relationship between hours of study and exam grades for the entire population. Therefore, null hypothesis RS equal to 0 and alternative hypothesis RS not equal to 0. Step 2. Determine the critical value for the Spearman rank order correlation coefficient, or R alpha, equal to. The critical value for the Spearman rank order correlation coefficient can be found in Table 3 in Appendix C at the end of this chapter on page 18-50. An excerpt of the table appears in Table 18.28. Using alpha equal to 0.05 and n equal to 6 for a two-tailed test, R alpha divided by 2 equal to 0.886, highlighted in yellow. Step 3. Compare the correlation coefficient to the critical value. Table 18.29 summarizes the decision rules for testing the significance of the Spearman rank order correlation coefficient. Because absolute value of RS equal to 0.771 is less than absolute R alpha divided by 2 equal to 0.886, we fail to reject the null hypothesis. Step 4. State your conclusion. Because we fail to reject the null hypothesis, we cannot conclude that there is a relationship between the hours of study and exam grade for the student population. You may find this conclusion surprising considering that RS equal to 0.771. However, Recall that this non-parametric procedure is not as powerful as the parametric procedure discussed in chapter 14, which makes rejecting the null hypothesis more challenging. Also, the sample size n equals 6 is very small, which makes rejecting the null hypothesis or finding a relationship less likely. This would be a good place to briefly discuss the logic of the Spearman rank order correlation coefficient. If the correlation between the two variables is both strong and positive or close to 1, we would expect the rank for each order pair to be close to one another. This would result in the summation of d squared from table 18.27 to be relatively small, causing Rs to be close to 1. If the correlation between the two variables is both strong and negative or close to -1, we would expect the rank for each order pair not to be close to one another. This would result in the D from table 18.27 to be relatively large, causing Rs to be close to -1. Thank you.